first I will do that homework, and then we will just go for the final two postulates, that is postulates 4 and postulates 5. So let's try to go for this. I have given this as your operator, and I hope this was operator A. And the question was, if A operator will measured on a state psi, and psi is very interesting, and this is written as 3, 4i. What will measurement with what probability? So first, if A will measure on a state psi, according to postulates 2, the measurement is eigenvalue. So you can find the eigenvalue here. Lambda I must be equal to 0. So you have minus lambda A naught minus lambda, and this must be equal to 0. So lambda is equal to minus A naught and A naught. So these are the measurement. The measurement is either minus A naught or A naught. Now, and obviously you have to find the eigenvector. So I hope you can find the eigenvector. So I am not doing this thing. So A1 is, let's say, minus A naught. So phi 1 you can find is all about 1 by root 2, 1 minus 1. Isn't it? So this is the eigenvector associated to A1. And you can find that suppose A2 is equal to A naught, you can find that phi 2 is equal to 1 by root 2, 1 and 1. So please, you have to find what is the eigenvalue and what is the eigenvector. And this is all you can do as exactly like a matrix you have done earlier. And please, eigenvalue and eigenvector must be orthonormal in nature. Because if you are not getting the orthonormal, then it will not follow the completeness relation. So I have deliberately written 1 by 2 here. Now, so these are the first thing. So what is the measurement? Measurement is minus A naught and A naught. And now probability of A1 is nothing but phi 1 psi mod psi square, and here is psi and psi. You can just write this thing as phi 1 as 1 by root 2, and this thing as 1 minus 1, and psi is 3, 4i. And you can just take mod square, and here is 3 minus 4i, and you will just calculate 3 and 4i. And if you will find this value is 1 by 2 into 50. So you will get 3 square plus 4i mod square. So this value is 50, and above that you can write 3 minus 4i mod square. And what is this value? This value is equal to 25 upon 50 is equal to 1 by 2. So I hope you have getting this particular answer. The answer is what? 1 by 2. And now we can go for the probability of getting A2 is similarly phi 2 psi mod psi square psi psi. This denominator term will be remain same, but above 1 by root 2, 1, 1 and 3, 4i, and you have to take the mod square. And here this term will again come to 25. So again you will have 3 plus 4i upon 50 mod square, and that is again 25 upon 50, 1 by 2. So you can easily find what will be probability of getting A1. A1 is nothing but minus A naught, and probability of getting A2. A2 is nothing but A naught. You will get the same thing. So if you have any doubt, you can just ask me. I hope you are getting this answer. And if you want to calculate the expectation value of A, then you can find probability of A1 into A1 plus probability of A2 into A2. And probability of A1 is 1 by 2. The value of A1 is minus A naught. Probability of A2 is 1 by 2. Value of A2 is A naught. that will be 0. So this will be the answer. So expectation value of A is actually 0. You can easily find, isn't it? So if you have any doubt, you can just ask me. Then I will go for postulates 4. So main thing is how you are getting this particular eigenvalue and eigenvectors. Okay. So let's try to go for postulates 4.
सर वो
And always keep.
प्रोबेबिलिटी में सर वो प्रोबेबिलिटी में हमें 25/17 आएगा ना कैलकुलेशन में
कैसे
क्योंकि
25/17 आएगा? हाँ
सर 4i का स्क्वायर तो 4i का स्क्वायर
4
मतलब
के
16 हो गया
हाँ
ना i स्क्वायर माइनस
जी नहीं,
मैं
नो नो
गलत
नो, मॉड स्क्वायर, मॉड स्क्वायर, मॉड स्क्वायर. हाँ, व्हाट इज वैल्यू ऑफ 3, क्या था, 3 - 4i into 3 + 4i. व्हाट इज दिस वैल्यू?
सर वो वाला नहीं, नीचे में जो हम लोग का साई
नीचे में
साई
ही
और
तो
साई
यही
का
आया था,
इनर
नीचे में यही तो आया है. नीचे में यही तो आया है, साई एंड साई.
सॉरी सर मेरा कैलकुलेशन एरर है, मैं करेक्ट
हाँ, साई एंड साई मीन्स व्हाट? 3 - 4i
यस सर, कॉम्प्लेक्स इनटू
एंड 3
कॉम्प्लेक्स कंजुगेट.
4i. हाँ,
हाँ सर मैं मेरा गलत थे, मैं करेक्शन करी हूँ, सॉरी.
ये गलती मत करना, जिंदगी बेकार कर देगा. Okay, so let's go for. So always you have to keep in mind mod square is very important. So I have deliberately given you 3 and 4i. In the real number it's okay, but when you have this particular imaginary number, be very conscious that you have to take the mod square. Anyway, so in the course of practice you can do each and everything. So let's go for a very complicated postulates, that is postulates 4. And what is this postulates 4 is all about the measurement of, suppose you have measured on some state psi. You can get any of the eigenvalue, a1, a2, a3, a4, any one the eigenvalue if I have an as my eigenvalues. At some particular instant, you can get any one particular value. What I am saying, I am just making you an analogy. We have coin. Before the tossing the coin, I can say the value can be either head or tail. So right now I am just going to toss the coin. The coin is just rotating and I can say, okay, head can become, tail can become, either head will come, tail will come. So there are probability to getting head also and probability to getting tail also. But once the coin is tossed, at the same particular moment, there is only one measurement. Means if coin is tossed and just when it is tossed and when you will see, you will just say, okay, head will the answer. And the same time, if another observer will come and he will say at the same time, then what he will say, okay, head is the answer. But again, if you are tossing the coin, after some time, again you are doing for the next measurement. You cannot give the guarantee that again head will come. It may be head, it may be tall, it may be tail. But again, when tossed is done, then what will be the value? Either head or tail, any one particular value. So this is all about postulates 4. So let me explain you. If, and we have postulates 1, we have postulates 2, we have postulates 1 and postulates 2, and postulates 3 is always there. Probability of an is all about phi n psi, mod square psi and psi. So it will tell you about the chance. Now, if someone measured state psi, he will get eigenvalue an on that particular measurement. On that particular measurement, he will get an. So state psi just after measurement of an is, so I am writing psi after, just after, psi after. Just after means you are not going to evolve the time. The time will be very minimum when the next observer is coming there. So just after, this psi after is basically phi n psi, and you can take the normalization part, that is psi phi n psi. So this is actually phi n. So what will happen? Suppose I have any state psi, and let's say this state is written as 2 5 plus 3 phi 2, and we have operator a, which is defined as a phi n is equal to n a naught phi n, means, and it is also given obviously phi n and phi m is delta nm. Now if operator a will measured on a state psi, hence it is written in a basis of phi 1 and phi 2, what can be measurement? Measurement is either a naught or 2a naught. So measurement can be either a naught or 2a naught, just as measurement can be head or tail. So you can just make a comparison. You can just make a comparison. Suppose I am tossing the coin, you can get either head or tail. Similarly, you can get either a naught or 2a naught. So these are the possibility. These are the possibility that either you will get a naught or 2a naught. Suppose at that particular point of time, suppose I am doing that some measurement at this particular point of time, let's say at exactly 6 o'clock, I will get 2a naught. What is meaning of that? Meaning of that, at that particular time, this psi is actually phi 2. So what will happen? The psi will be collapsed in a direction of phi 2. So this is very interesting. So psi will be collapsed in a direction of phi 2. At that particular time, the psi will lose all its nature, and only remaining nature is the phi 2 from this particular thing. So this is a very strong postulates, and this is the most difficult postulates to understand also. Why? Because once you are measuring, and suppose you are getting a2, sorry, 2a naught, means your psi will become phi 2. And after the next measurement, as again you are going to toss it, can be possibility. Again A naught or 2A naught. And this time, suppose you will get measurement A naught. Means that time your psi will be in a state, in an eigen state of phi 1. So what will happen? As your measurement will, as you will measure the particular operator on any state psi, you will get some eigenvalue, and that time the psi will be collapsed in that particular direction. And in the another time, the psi can be maybe collapsed into another particular direction. So what will happen to particle? So particle will continuously changing its state. It may be something like this. So this is analogically you can just understand with this particular head and tail thing. Suppose we are doing toss and you are getting head. It will not give you guarantee that next time you will get head. What you can say, you will get either head or tail. So suppose in that particular time I will get A2, means what is meaning of getting A2? Means the psi will be fully collapsed in a direction of phi 2. So if you have any doubt, you can just ask me.
सर ये कुछ प्रोजेक्शन ऑपरेटर की तरह है क्या, जैसे प्रोजेक्शन का साई फाई के डायरेक्शन में
बिल्कुल 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 आप लिख सकते हैं इसे प्रोजेक्शन फाई एन. बिल्कुल गुड. मीन्स नाउ आई कैन यूज द बेटर वर्ड. जो भी आइगन वैल्यू आपको मिल रहा है at that particular point of time, psi will be projected in a direction of eigenstate. Example दे करके देखते हैं. Suppose what you can. So, are you getting this thing?
Hello, sir. सर ये psi क्या लिखे हैं जो ब्रैकेट में लिखे हैं, क्लियर नहीं हो रहा है.
Psi after the measurement है ना. After psi after है ना, just after measurement. This is the important word. Okay.
सर
हम्म.
सर ये साई आफ्टर के जो डिनोमिनेटर में लिखा है हमने, सर वो कि हम नॉर्मलाइज करने के लिए लिख रहे हैं.
नॉर्मलाइज करने के लिए लिखा है. बिल्कुल
Okay.
बिल्कुल 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 बिल्कुल. Very good. Now let's try to go for a problem. Then I will make the final statement. And obviously just after measurement को हम दूसरे तरह से बोल सकते हैं simultaneous measurement. Means the another thing will be measured, only they will commute, isn't it? So we are talking about actually simultaneous measurement. Look at with the example. From example you can understand it better. So what is the example? Suppose I have any operator A, phi n is equal to, let's say, n a naught phi n. N can be written as 1, 2, 3 and so on. And the state psi is given as 2 phi 1 plus 3 phi 2. प्लीज किसी का माइक ओपन है, ये बंद कर दो, है ना. सो सपोज A will measure on state psi one will get phi 2 just after measurement of A, just after measurement of A, operator B will measured on state psi. So this is my first question. And B is defined as B phi n is equal to n square B naught phi n. What will be measurement? What will be measurement? So in the first part of this problem, if A will measured on a state psi, what can be possibility? Possibility will be A naught or 2A naught. But what you will get? You will get 2A naught. Why? On a state psi, one will get phi 2 means you will get 2A naught. One will get phi 2 means you will get 2A naught. So at that particular time, again B will measured on a state psi. Then at that time, the psi will be not in a basis of phi 1 and phi 2, rather at that particular time, psi will be in direction of phi 2 because the measurement is 2A naught. And then B will measure on state psi. What he will measure? He will measure actually phi 2. So what is measurement? The measurement is 2 square B naught, that is 4 B naught. Are you getting this thing? If you have any doubt, and this is all about postulates 4. And now the question can be again raised. So are you getting this thing? I can go for the next level. Suppose,
explain again. Sir, can you please explain again? Sir,
my
how
question is,
phi 2 is 2A naught?
because A will measured on a state psi, one will get phi 2. So what is eigenvalue of related to phi 2 from here?
Acha, n is equals to 2, so 2A naught.
Yes. So you will get 2A naught. Okay. And once you will get 2A naught, at that time, again you will measure B. And how you will measure B? The rule of B is given here. N square B naught. So B will not going to measure directly on psi. B is going to measure actually on phi 2. Phi 2. Phi 2. And once B will measure on phi 2, what you will get? You will get 4B naught. Okay. So this is all about postulates 4. And now if I will ask you the same question after measurement of B on state psi, again B will measured on state psi if time is evolved. If time is evolved, what will be measurement? What will be measurement? Now again time will evolve, means psi will again come into its original state. And what is B? B is given B phi n is equal to n square B naught phi n. So again, if time is evolved, the state psi will be again in the basis of phi 1 and phi 2. So now you will use, when time is going to evolve, you have to use postulates 2. When time is not going to evolve, then you have to use postulates 4. So time is evolved means you are doing the next measurement, means your psi is again going to settle down. So again, if psi is going to settle down, means it will again come to its original form. And not actually original form, but basis will remain same. But basis will remain same. Then what will be measurement? The measurement will be now, what will be the eigenvalue of B? The eigenvalue of B is basically 1 square B naught, that is 1 B naught, and 2 square B naught, 4 B naught. So what will be, if time is going to evolve, what will happen to state psi? It will again come into its original state, and you can measure B naught or 4 B naught according to postulates 2. So you have to be very much careful that whether time is evolved or you are doing the instantaneous measurement. If you are doing the instantaneous measurement, obviously one of the eigenstate is relevant. But if you are going for evolution of time and you are going for the second measurement, and then you can have this particular thing. Same thing, as toss is going to happen, either head or tail can become. But once toss will done, then you will get one particular value, and that will be certainly head or tail. That depends on what is the outcome. So if you have any doubt, you can just ask me. Then I will go for the final postulates 5.
Sir,
Mhm.
sir, after some time when psi comes back to its original form, will the coefficient 2 and 3 also be the same?
No, that will be not remain same. That will not remain same, and that will change due to postulates 5. But measurement will dependent on the basis, so basis will remain same.
Okay, sir.
But there is some phase factor will come into the picture, and that phase factor will come with your basically postulates 5. Okay. So we will just discuss what will time evolution actually. So I have just used the time evolved. Okay.
Okay, sir.
Okay. So let's go for next postulates, and we are now everything is done. Last postulates is the easiest one, that is Schrodinger wave equation. So let's go for Schrodinger wave equation. Okay, so the postulates 5. Time evolution of state. Time evolution of a state. And for that, we have to solve the Schrodinger wave equation. So I am just using this notation, and this will be H is equal to, sorry, that will be H, and let's say UN. I am using this UN for the energy actually. So don't worry. Otherwise, you can use phi 1 also. So H UN, and you can take phi 1. Take phi 1. Don't worry. So you can just write H phi n is equal to IH cut del upon del T phi n. And what is H? H is nothing but the Hamiltonian operator. So H phi n is equal to En phi n. So H phi n is equal to En phi n. And what is En? En is energy eigenvalue, and phi n is energy eigenstate. So this is all about energy eigenstate. So what you will do, h phi n, so we have first order differential equation. So we have En phi n is equal to I h cat phi n. Sorry, this will be del upon del t phi n, and we can just do this particular differential equation very simple. So this will be En upon I h cat, and d del t I can take. So del phi n upon phi n, you can just go for integration. So if you are integrating it, just go for En upon I h cat t is equal to phi n ln phi n t plus some constant. And yes, you know the initial condition. Then you can only tell about the time evolution. So you have initial condition. So what is initial condition? So you can take phi n. So phi n at t is equal to 0 is phi n 0. So let's say this is the initial condition. So when you will put, oh, क्या हो गया?
So what you write ENP इसके बाद क्या लिखोगे?
कहाँ पर? This one.
जी
Hmm?
जी वही लाइन
So En t upon I h cat नजर नहीं आ रहा है क्या?
सर आ रहा है उसके बाद वाला बहुत छोटा क्लियर नहीं है
अरे यार छोटा क्यों हो गया? ln phi n t plus c. किसी मोबाइल में देख रहे हो क्या?
सर लैपटॉप में देखिए थोड़ा बैंडविड्थ
अच्छा अच्छा ठीक है, चलो अभी समझ में आ रहा है क्या है ये? ln phi n. आप इंटीग्रेट करो ना, इसको इंटीग्रेट करोगे तो ln आ जाएगा, है ना? ओके. So what we have basically En t upon I h cat is equal to ln phi n t plus c. We have to find the value of c. So we have at t is equal to 0, phi n t is equal to 0 is equal to phi n 0. So I have initial amplitude. So this will be 0 is equal to ln phi n 0 plus c. So c is equal to minus ln phi n 0. I am using very crude way to derive this thing. It has lot of sophisticated way, but I am just using directly. So you have ENT upon I h cat is equal to ln phi n t minus ln phi n 0. So what you can write? You can write ln phi n t upon phi n 0, isn't it? So now we can have time evolution. We can have time evolution. Up to that, everybody is okay?
Yes, sir.
Okay. Okay, so what you can do, you can just write phi n t is equal to phi n 0 e to the power. I can take I on the numerator. So this is minus I en t upon h cat. So what will happen? The energy eigenvalue is going to evolve with the time. and there is a phase factor depends on energy eigenfunction or energy eigenstate is going to evolve with the time, and what you will get energy eigenvalue as the numerator. This is the thing, and this is just a simple phase value. So this will be depends on the phi n, phi n. So suppose you have another state, let's say phi m. What will happen? You have phi m 0 e to the power minus I em t upon h cat. So the Hamiltonian operator have two purpose. The first purpose, it will just tell you the measurement of energy, and second purpose, it will also tell you how your state is going to evolve with the time. So whenever you have to go for the time evolution of a state, what you have to do? You have to represent your state in a basis of energy eigenstate. Now, and once you will write it, you can easily say how this thing evolving with the time. Let me explain you. Up to this, are you getting?
Yes, sir.
Okay. So let's go for a final version of how, and right now I am just talking about the how the energy eigenstate is evolving with the time. So suppose I have a Hamiltonian operator. So why Hamiltonian operator is so important into the quantum mechanics? In the classical mechanics, how time is going to evolve? In the classical mechanics, from the Newton's law of motion, the time is going to evolve. But in a quantum mechanics, the time evolution of a state cannot be determined by the Newton's law. Rather, it is determined by the Schrodinger wave equation. And you can easily find how we can use this thing. Suppose I have Hamiltonian, and this obviously H is Hamiltonian, and H phi n is equal to En phi n. And I have another eigenstate, energy eigenstate, phi n is, let's say, Em phi m. And it is also given phi n phi m is delta nm. Now, suppose at t is equal to 0, I have any state psi, and this is given as, let's say, Cn phi n plus Cm phi m. So what is written? The state is written in a basis of energy eigenstate. And obviously this is at t is equal to 0, means this is at also t is equal to 0, this is at also t is equal to 0. And at t is equal to t, and this is at t is equal to 0, that will be psi t can be written as Cn phi n t plus Cm phi m t. And now, how this phi n t is going to evolve? Something like this. So, what will happen? This Cn phi n0 e to the power minus I En t upon h cut plus Cm phi m0 e to the power minus I Em t upon h cut. So this is the psi t, isn't it? So what is this thing? This thing nothing but a some complex number. And after time t, what will happen? The psi t will have same basis of energy eigenvalue. And how I can write it? we can write it psi t, and psi t is equal to Cn e to the power minus I En t upon h cut plus Cm e to the power minus I Em t up, sorry. So this will be, you can write phi n0 plus Cm e to the power minus I Em t upon h cut phi m. Now you can see I can represent this whole number as some new number. So what will happen? Psi t is equal to, let's say this is Cn dash phi n0 plus Cm dash phi m0, isn't it? So this is all about the thing. So what will happen? The basis will remain same. This coefficient is going to evolve with the time. This is a number, this is a number. And the beautiful part is that when you will find the norms at t is equal to 0, so norms at t is equal to 0 is psi 0, psi 0. This is the norms. You remember I have given you this thing, norms of psi 0, and hence they are orthonormal basis. They are written in orthonormal basis. Phi n and phi m is delta nm. Then this norms is nothing but root under mod cn square plus mod cm square at t is equal to 0. Now, when you are going to find the norms at t is equal to t, so you are just going to find the norms at psi t, then this is nothing but you will get mod cn dash square plus mod c dash square. And please look at very carefully. The Cn dash is nothing but Cn e to the power minus I En t upon h cut, and mod Cn dash is nothing but mod Cn. The magnitude of both are same, and similarly you have mod Cm dash is equal to Cm e to the power minus I Em t upon h cut, and this will be mod Cm dash is equal to mod Cm. And what you can get? You can get the same norms. Isn't it? You will get this exactly. This is at the t is equal to t. Sorry, this is at the t is equal to t. So what you will get? The norms is remain same. The basis will remain same, but you will new. But if you are changing this coefficient, you will have new vector. Isn't it? But what is going to remain same? The magnitude is remain same. Is going to remain same. If you have any doubt, you can just ask me.
Sir,
Hmm.
so you said that we'll get a new vector. Will this vector be parallel to the original vector?
No, not parallel. Who said that is parallel to you? Never, not parallel. It is evolving with the time. It is going to rotate. Look at what is going to happen. So, can I rub this thing or erase all this part? Then I can discuss it. Okay.
Sir, it means that the coefficients at t is equal to 0 and t is equal to 1 will become equal, sir. Mod of.
At any particular time. So look at what will happen. Suppose you have any state psi, and let's say this is at t is equal to 0. The state will be different and this will be t is equal to t. What will happen? The magnitude will be remain same. So this is just rotate. It may be some particular time it will be become 90-degree, perpendicular, orthogonal. At some time, suppose at some particular time, we will just calculate. After some particular time, it will become perpendicular. It may be after then, they will just like this. After some time, it will again get the same thing, become parallel also. So what will happen to state? The state is going to rotate actually, because I am just taking the 2-dimension thing. So I am using the worst rotation in a plane. Otherwise, if n-dimensional, you can just only say the direction is going to change, but norms will remain same. Are you getting this? That girl who have just
Yes,
asked
sir.
before that? Huh? So
Yes, sir.
it may be possibility that it can be perpendicular. It may be possibility that it will be parallel. Okay, after some time t. So let's try to calculate what will happen when it is going to perpendicular. So let's try to go for this. So
सर डीजनरेट केस के लिए प्रोबेबिलिटी क्या होगी?
क्या हो गया?
डीजनरेट केस के लिए प्रोबेबिलिटी
अभी वो कहां से आ गया यार? तुम लोग शांत नहीं बैठ सकते हो कुछ देर क्या? प्रोबेबिलिटी होगी, जैसे वहां निकाला तो यहां भी निकालोगे.
ओके सर.
अभी क्या बात कर रहा हूं, कहां चले गए? मतलब अजीब सी स्थिति नहीं है ये? जैसे वहां निकाले तो वैसे यहां भी निकालोगे प्रोबेबिलिटी. बात करेंगे उसके बारे में. So obviously we have psi at t is equal to 0 is something cn phi n plus cm phi m, and obviously we want to calculate after what time psi t is orthogonal to psi 0. So what do you have to do? You have to just go for psi 0 and psi t become 0. This is the orthogonal relation. And when you are going to calculate it, then you have cn star cn e to the power minus I en t upon h cut. Just you could take the scalar product. Phi n will be 1. Phi m will be 1. So only these two part will be there. And plus cm star cm e to the power minus I em t upon h cut must be equal to 0. And this is nothing but mod cn square e to the power minus I en t upon h cut, and this will be mod cm square e to the power minus I em t upon h cut must be 0. And from here we can calculate the thing. So how you will calculate it? You can just write. So I can write e to the power minus I en t upon h cut, and you will take it in that side, and I am dividing it. So e to the power minus I em t upon h cut is equal to minus mod cm square upon mod cn square. And please, this is a complex number, so you have to always keep in mind. So if it is complex number, you can write e to the power I t upon h cut. This is em minus en must be equal to minus mod cm square upon mod cn square. So I will just equate the real part. So when you will equate the real part, so you have cos em minus en T upon H cut is equal to minus mod Cm square upon mod Cn square. And now, please, one thing you have to keep in mind that when you are doing this reciprocal, you can also write Em by En. Then this will be go up and down. So how you will take the reciprocal thing? How you will take this ratio? This ratio will be always between 0 to 1. This number must be always between 0 to 1. Why? Because this is the cost number. This is a cos. So you have to always keep in mind. So this will be cos Em minus En T upon H cut must be minus mod Cm square mod Cn square. And you have to just find this will be T is equal to nothing but H cut upon Em minus En, and you can take the mod value cos inverse mod Cm square upon mod Cn square. But the restriction is that this value mod Cm square by mod Cn square must be between 0 to 1. Isn't it? Because this is cos value. This is the cos value. And suppose you are taking this type of reciprocal thing and it will come 2, then what you will do? Suppose mod Cm square upon mod Cn square will come 2. What you will do?
The mod cm square by mod cm square.
Yes, you will just do the reciprocal thing. You will just go for the reciprocal because we are in the ratio. Okay, so ratio must be between 0 and 1. This ratio, always keep in mind that this thing must be between 0 to 1. You cannot write arbitrarily because right hand side 0, it will depends on which part you are taking on right hand side. Either you can take mod Cn square there or you can take mod Cm square there. Depends what is the ratio. So always keep in mind this particular thing. This is most important thing. Okay. So now you can see we have, and
Sir,
if this number, yes.
सर फाइनल एक्सप्रेशन में एक माइनस रहेगा ना cos
minus
इनवर्स के
रहेगा.
अंदर.
That will be minus. Yes, yes. That will be minus sign. That will be minus sign. Take it minus sign. Okay. So, but I will suggest you don't use as a formula. Use with a first principle. Okay. Just do this particular thing, and after then you can take the ratio accordingly. And please, this time is time after. You cannot tell about the time before. So if sometime this can become negative, so you have to take the mod value. Then this thing I have taken deliberately for the mod value. So always time will be after some time. Next time what is going to happen? I'm not talking about what will happen before. Okay, so time must be always positive. So you have to be very much careful about the ratio as well as the sign. Okay, so this is the most important thing. So we have just finished all about the postulates 5, and postulates 5 will tell you how you can just evolve the any state, and that will be Hamiltonian will come into picture. So tomorrow I will just go and solve different types of problem, much more analysis all about. Tomorrow we will also discuss about how probability density is going to evolve with the time, and then we will try to discuss 1 or 2 problems based on this particular postulates. Okay, and then tomorrow we can just solve different types of problems. So please revise each and everything, because I don't want now you will you will just puzzled in a simple calculation of eigenvalue, eigenvector, orthonormality. We have done a lot of this thing. So now tomorrow I will use each and every point, each and everything whatever I have discussed from 1 to postulates 5. So tomorrow is the final class of postulates. Okay. If you have any doubt, you can just ask me.
So we have used the Hamiltonian operator to find the time evolution, right? So
Yes.
due to this reason, is that the reason for the, I mean, if we use a Hamiltonian operator, the norm of the state will not change. Is that so? Or any other operator acting on psi will not change the...
No. For the time evolution, you have to represent your psi in a basis of Hamilton energy eigenstate. That's it. Okay. Suppose you want to measure the momentum, then you will write the psi in a basis of momentum eigenstate. Suppose you want to measure the angular momentum, then you have to write the state in a basis of angular momentum eigenstate. But for the time evolution, you have to represent in term of energy eigenstate.
Okay, sir. Thank you.
Okay.